Hello everyone. In this video, I'm gonna explain you about IEEE 802.11 protocol and its system and protocol architecture. So let's get started. First of all, let me tell you something about IEEE 802.11. So it is the most famous family of W lines. W lines means wireless lines, in which many products are available almost every devices, and it belongs to the group of 802.x line standard. As you can see, we have 802.11, so it is it belongs to the group of 802.x. So the primary goal of this standard was the specification of a simple and robust double line, which offers time-bounded and asynchronous service. How does that? We are gonna see that later. So it works on the frequency band of 2.4 GHz ISM band, which is most common and is available worldwide. And the data rate, it can offer two data rates. So one is mandatory and another is optional. 1 megabit per second is mandatory and 2 megabit per second is optional. It includes the support of power management to save battery, the handling of hidden nodes, ability to operate worldwide. So how it has the ability to operate worldwide? That is because of its frequency band, as I told. And about the power management and handling the hidden nodes, we can see that. In the we will see this later. So I'm going to tell you about system architecture. So system architecture can be implemented in two ways. One is infrastructure based, another is ad hoc. So as name suggests, infrastructure based have infrastructure and ad hoc doesn't have an infrastructure. So we don't need infrastructure for implementing ad hoc system architecture for this product. So first of all, let me tell you about infrastructure based system architecture. So as you can see in this diagram, let me tell you some abbreviation first. STA means station, ESS means extended service set, BSS means basic service set. I think there was a typo there. And as you can see in this diagram, we have several access points, and each access point is connected with a basic service set. And each basic service set has one or more stations. And each access point is also connected with distribution system, and this distribution system have portal which connects us with other 802.x LAN devices. And many BSS are grouped together to form a ESS, that is extended service set, and this ESS has its own ID and we call that ESSID, which is used to identify any extended service set. Without it, we cannot identify any extended service. So this is all the infrastructure-based system architecture, and I'm going and everything written here. I explained you everything in this diagram. We have access points, BSS, ESS, and portals connected with other devices, and access points are connected with BSSs and distribution system. So what it does, patients can select an access point and associate with that. And the access point supports roaming. The distribution system handles the data transfer between the different access points. Access points provide synchronization within a basic service set, support power management, and can control medium access to support time-bounded services. Now, another one is ad hoc system architecture. As you can see in this figure, we don't have any distribution system or portal and to connect with other devices. We have IBSS here. IBSS means independent basic service set. That is a basic service set which is independent of other basic service sets. They are not connected with directly. So as you can see in figure, one IBSS have three stations and another IBSS have two stations. And you can see they don't have any direct link with each other. STA1 can communicate with STA3 directly but cannot communicate directly with STA5, which is in another IBSS. So to communicate with another station which is in another IBSS, there should be a mechanism. So there are, and but not directly. They cannot communicate directly. An ad hoc system architecture. So that's what ad hoc system architecture is, and that's how it is implemented. You can see that in film. Now, let's move to protocol architecture. As you can see, we have a mobile terminal which is connected to access point, and then infrastructure network, and then a fixed terminal. So, protocol architecture basically, the protocol architecture of 802.11 standard, basically based on physical and mechanical. And we and these layers are further divided into sub layers. As you can see in figure, we have PMD, PLCP, and MAC. And on the top of MAC, we have LLC, that is Logical Link Control Layer. And MAC and LLC are associated and grouped together to form DLC, that is Data Link Control Layer. And we have PLCP and PMD. So how it works? Let's see this. So the IEEE 802.11 standard only covers the physical layer and medium access layer, as I told, and every other 802.x lens does the same also. The physical layer is subdivided into the physical layer convergence protocol, that is PLCP, as I shown in the figure, and the physical medium dependent sublayer PMD. The basic task of the make layer compromise medium access, fragmentation of user data, and encryption. So the MAC layer does the basic tasks such as medium access, fragmentation of user data, and encryption. And the CSA provides a common physical service access point, that is SAP, which is independent of the transmission technology. So finally, the PMD sublayer handles modulation and encoding decoding of signals. So PMD basically does modulation and encoding and decoding of the signals, and and the physical layer and the MAC layer will be so that will be explained later. So let me tell you about. Let me give you the briefing of them. I'm not covering these layers in details because that's not into my topic. So you can refer to some other tutorials or other books to understand, to dig further into these layers. And apart from the protocol sublayers, the standard specifies management layers and the station management. The MAC management supports the association and reassociation of a station to an access point and roaming between different access points. It also controls authentication mechanism, encryption, synchronization of a station with regard to an access point. And also, it maintains the power management to save battery power. Mac management also maintains the Mac management information base, that is MIB, and the main task of the physical management include channel tuning and maintenance. So finally, station management interacts with both management layers and is responsible for additional interaction with distribution system in the case of an access point. So that's how protocol architecture works for 802.11 standard, IEEE 802.11 standard. So that's it from me. Thank you so much.